I'm going to give you a little historical perspective. It's always a good place to start. And I'm going to talk about what's next, and I'm actually going to shoot just beyond service mesh. So stay with me on that one. I'm not going to talk about service mesh narrowly. I'm going to talk about it very generally, which is where I think things are going. So historical perspective, I thought I'd start with a historical artifact. Hopefully you're familiar with it. One of the most beautiful pieces of computer science, right? It is so minimalistic. If we could just all agree to those few bits on the screen, it's not aesthetically pleasing to look at, obviously, but it's that universal thing that if we could buy into, we could build a global thing. But you have to keep it minimal, right? So this is where it all started. And in fact, you're, I'm sure, familiar with the notion of the internet having a narrow waist. IP is manifested by that ASCII diagram, was the narrow waist of the internet circa 1980. It was minimal, it got things started. It wasn't the end of the road, of course, and I would argue that I think we all recognize that the waist has moved up. The narrow waist of the internet is now HTTP, and again, it's the universality of being able to do gets and puts on identifiers for anything in the world, URIs. And of course, it had a little help with security and some congestion control management underneath it, but that's basically the narrow waist of the internet as we know it today, and that's allowed for the explosion of cloud services. So, of course, that just begs the question, what's next? And I'm going to just draw it in very broad strokes. I'm going to use this phrase as a kind of a catch-all, everything is a service. And that is, in fact, where things are going. Everything that they're concerned about are services. We used to be concerned with URIs and objects, resources at a kind of a low level. We can now build services. So how do we orchestrate, manage, and build new things out of services? So you might have expected me to say service mesh. At the top there, I said service chain. That's part of my intent to try to stretch you just a little bit beyond what we're immediately trying to do. And below, it's not that we have this world full of networks. We now have a world full of clouds. And so it's really, and I don't know exactly what's going to go in that narrow waist. I'm going to label it everything as a service. But that's what we're all about for the next few years, trying to figure that out. So if the manifestation of the architecture almost, 40 years ago was that ASCII diagram, what's it going to look like in the future? And this is just one possible example. I think it's going to be a model definition. And this particular model definition, you can look at it and you're probably going to recognize it looks a little bit like protocol buffers, and it syntactically is a way that we, in a system that we're building at ONF, which I'm going to use as an example as I go through this, are using to specify the behavior we want out of a system. And it's our hammer as we try to figure out how to build these more complicated things from all the disaggregated parts that we've created. This particular variation of protocol buffs, we don't just use it to generate code to marshal arguments. We use it to generate a lot of code, and we've extended it slightly. It all fits in the option field, but we call it xproto. And it's basically, like I said, just an example of the specification language for models that define the architecture. I'm going to use this running example as I go through a few slides here. So I said it's a multi-cloud world. So this is going to be my way that I'm going to just draw a multi-cloud world. And everyone understands that the edge cloud is now the big deal. We're going to get applications out near where the end users are, where their devices are, low latency, high bandwidth, supports mobility, and so on. Except this doesn't actually exist quite yet. And what in fact is there at the edge today is another historical artifact. If you go into the access networks of all of the network operators, you will find what they traditionally call the central office. It is a network museum. You might find 300 different pieces of equipment, bundled, proprietary. It's still hooked up to the billing system, so it doesn't get thrown away, but it's not the cloud that we all hope it to be. So this is basically where the ONF is working, which is we're basically trying to do to that piece of the infrastructure what everyone else in the cloud has been doing all along, which is to virtualize, commoditize, and disaggregate what used to be there. And when we're done with that, we hope then we have this end-to-end cloud that we can take advantage of. And just to put a name on this, if you've heard of it, this is the CORD project, which is the central office re-architected as a data center. So it's trying to bring this technology to that environment. Now, having done that, what do you end up trying to do? And basically, this is where I'm going to use the word service chain. We're trying to make it possible to construct functionality on behalf of individual users, subscribers, applications, devices that stretch across that multi-cloud. Let me call it a service chain. You're going to see it's an instance of a service mesh, but I'm going to call it a service chain. And just so I'm clear, I'm going to have a little bit of a focus here on the access edge that you might find in a central office, but don't let yourself think that it's limited to that. It also stretches on-prem. So that's, in the telco infrastructure is one place this technology will go, but that's not the only place. And so these are, in fact, all the way to on-premise, into your house, into your enterprise. But the important thing to take away from this picture is this is now a mobile world. And so as you leave home and you get in your car, this potentially follows you. So this is the thing that we're after, that I'm talking about, that is where the service mesh, I believe, is going to end up. Now, it turns out, I've been in networking for, 30 years, and I knew practically nothing about the access network. And I understand that is the case for almost everyone except those that live in the telco world. And so I want to just take a minute to talk about what we're doing there so that you can appreciate the problem that you have from that. So what we're doing is the same thing that's been happening in the web services space for quite a while now, which is you bring disaggregation to the game. Except we're bringing both microservices and SDN. And so you take these very large bundled devices that you used to buy from a traditional vendor, and the first thing you do is you break the control plane and the data plane, and we use commodity white box switches there. Then you do the second obvious thing, which is you break the big functions into a bunch of microservices and you build meshes out of those. And the third thing that you do is you move some functionality that you had in a microservice back down into the switching fabric. And so these are now programmable devices. So when you think of the applications that we're building, don't think of those applications as only running in some format on a server. They're running in the switches as well. So those pipelines are increasingly powerful, and there's certain work that you really ought to be doing there and not have to hit a server. Let me just draw a comparison just for a moment, and this is one of those, lock this one away and come back to it later. Those little functions that got dropped down in the switches, imagine that's Envoy. It's functionality that I can put into the data plane, customized for some purpose, not just the standard yesterday's forwarding packets. So this is just another example of where functionality might live. All right, so I could walk through examples of how we've disaggregated the passive optical networks and the RAN and the radio cellular networks, but I'm not going to do that. Just assume for a moment that we have broken these things into pieces. That really leads us to the hard problem that we're about here today, which is putting the pieces back together again. And so that's the integration problem. And it's really interesting. It seems that the obvious thing to do is to break things into pieces. It's what actually spurs innovation, and you become more agile and improve feature velocity and all of that. But if you think about this from the telco's point of view, they have, and the same is true for cloud providers, they have to take those parts and put it back together again. And if you don't put them back together again in the right way, you've just thrown away all the advantages you had from disaggregating those parts in the first place. You get a brittle system that was integrated as a one-off solution. But you have to do that to operationalize it. So the central challenge is, how do you automate the process of operationalizing a system built from disaggregated components? That's a challenge we've been facing in Cord. That's a challenge of service mesh. It's a shared challenge. The approach that we're taking is we would like to declare with intents what we want from the system once we put it back together. We don't want to have to hardwire a bunch of stuff in, and then we can't change it, and we can't keep pace with the change. And second, we want to centralize the control in the operationalization of that system. The last thing you want to do is to have to manage each of the individual components independently. You want to manage it as a complete system, as a complete service mesh, and not have to manage the individual parts. Disaggregation was good for innovation. Disaggregation is what you're working against as you try to integrate and operationalize. So this is the shared problem that we're all here about. It exists in many different forms. All right, so let me try to put a little bit of meat on the bone with some details about a layer that we have built that I think, at the end of the day, has an interesting interplay and complementary to what Istio is doing. And I hope to draw out that comparison, but it just shares a lot of problems as well. So it's a modeling language, a generative tool chain, which I won't really talk too much about, and some core models. So this system is I think of it as an operating system. That's just the way we approached it. That's why it's got the name it has. But it's basically a service control plane. And when I say service, do not think Kubernetes service. Kubernetes service is a particular implementation of a service. But when you start implementing functionality in switches and you implement them in serverless places and so on, the implementation might be different. So I'm talking about an abstract service. So I've got a whole bunch of disaggregated components. They might be legacy, what the telco world calls VNFs, virtual network functions running in VMs. It might be horizontally scalable microservices. It might be control applications running on top of an SDN fabric or whatever. Those are the disaggregated components. And we're basically, those live in the data plane, the service data plane, and we're just basically trying to glue those together and manage them as a compound unit and a control layer. If you look internally, what you'll find is that there's a data model, and that's the key here, that from which once we have the model, we can generate the northbound interfaces, we can generate a whole bunch of glue code that makes this thing behave as a single unit. There's a synchronization framework that ties the data model to all those back-end services, and we load this with some core models. And I'm not going to go into detail, but the core models are services, service dependencies, service instances, and so on. And then each of the individual services that we want to integrate into that mesh load their model into the system. There's all kinds of cross-references, a lot of interconnections, and a lot of richness. In fact, if you look at that poor orphan service, the black one over at the right, there's nothing behind it because it's a purely logical service. And that's a really, really important point. Where we're trying to get to is that you actually now start programming services in the abstract as opposed to programming services, concrete implementations of services. You can build services out of services. And that's, in fact, we've done that. That's what that example on the right is. All right, without, again, going into a whole lot of detail, I want to draw out, call attention to what happens once you have those models. And basically, you build a service mesh, all right? And I've color-coded this just to remind you that while we're at the abstract layer here, behind those, some are blue services because they're implemented in the switching fabric. Some are red services because they're implemented in microservices. Some of them are gray services because they're purely logical, implemented out of other parts. That's the service mesh. It's exactly the same idea at the abstract level. Remember, there's an implementation below it. And then we implement service chains, are basically combinations of instances that have been allocated to a particular use case. It could be a subscriber, it could be an application, it could be an end device. That's completely up to the definitions that you want to invent. So this is the service chain that I was showing you earlier. It's basically, it's a multi-tenant. The services in the service mesh are multi-tenant, and these are the instances of the multi-tenancy. One of the things to call attention to here, though, as we look to the future and where these technologies all come together, is that having control and visibility at fine grain is one of the difficult problems that you have to pay attention to. So whether you're tracing for debugging purposes or you're providing fine grain visibility through the service mesh because you want to actually monetize a customized path for someone is up to you, but that's basically the same problem. So this is slideware. We have built a bunch of these. In fact, this is a multi-cloud service mesh that we've been working at ONF with Tetrate on. This happens to be an implementation of the access network for cellular, for 5G. Again, I won't go into all the details, but color coding is important here. The blue services, the functionality are implemented in the switches. The red services, the functionality is implemented in containers. And in fact, it's multi-cloud. These services live at the edge. These services live in the Google Cloud. And while I'm showing a CDN and a video archive as one example from a point of view of a demo, there could be many edge services, and there can obviously be many cloud services. Okay, so this is something that's real. If you look into the details of this, you start to see interesting interplay between all the levels of the network stack. A lot of what we've been doing at the edge is at L2 and L3, and obviously what's happening with the service mesh is at L4, L7. but the problems are exactly the same as you go up and down the stack. And I think that's where there's an interesting opportunity as we go forward. So just a quick summary of some of the takeaways. The access network is being codified. Be aware of that. It's going to be really important. Operationalizing that edge is a really challenging problem. It's exactly the same challenge that we're all facing as we talk about service meshes. The access edge will be a critical part of the multi-cloud, and don't think it's limited to the telco. They happen to have a monopoly on it today, but that's not the way it's going to play out, I believe, in the future. This technology, 5G, and the mobility that it supports in unlicensed band is going to be critical for low latency mobile edge applications across enterprises as well as in the telco networks. And the support for mobility is obviously important. And finally, as we think back to the narrow waist, and I don't know what exactly it's going to look like, but it is going to be some notion of everything is going to be a service. There's going to be meshes of functionality broadly. There are going to be service chains of functionality allocated to individual subscribers. And that's basically where we're moving. That narrow, fine-grained runtime control is going to be important. And finally, there is a really, really rich opportunity here to get out of our silos and think, I only work at this level of the protocol stack. These problems are exactly the same as you moved up and down, whether your functionality is implemented in an Envoy proxy or it's implemented in a switching pipeline. It is still functionality that gets you from point A to point B, and it needs to be managed and operated. And so these problems are common across the spectrum. So I think with that, I will stop and pass it on to Eric. Is that the? Okay, thanks. Thank you.